Okay, 2.5 zeros of a polynomial. We will be using synthetic division, long division, while we do these things. We know that an nth degree polynomial can have at most n real zeros. You don't need to write this down. You already have it written down. We know it has at most n real zeros, but you know what? It doesn't have at most n real zeros. It has exactly n zeros. And this one says precisely. It's right here. Complex, under the complex number, every nth degree polynomial function has precisely, I like exactly, n zeros. What word is different from what I underlined down here? Nope. Look at it better. Real. Okay? With imaginary numbers, we have imaginary solutions. So if I have x to the 10th, how many zeros are there? 10. It says 10th degree polynomial. Did I say real zeros? No. It has 10 zeros. This is called the fundamental theorem of algebra. This is it. The fundamental theorem of algebra says a complex number, under the complex number system, every nth degree polynomial function has precisely n zeros. Every one. Doesn't matter. But they didn't say they were real. Just the bottom part's a side note for me. The fundamental algebra theorem of algebra, tells you that the zeros exist. They do not tell you how to find them or what they are. Do you understand what I'm saying? They say they're there, but that is it. Nothing else. Just like the leading coefficient test tells you what the n's do, but nothing else, right? Tell me when I'm good.
Good.
Riley's still writing. I do.
Good.
Okay. So, find all zeros. We've got 4 examples on this. Find all zeros. So, how do you find the zeros of a function? You set it equal to what? 0. So, what would you do on the first one? Add the 2. So, x equals what? 2. You do that in your head, right? That's a factor, basically. That's all it is. Okay? What about the one on the bottom? F of x equals x cubed plus 4x. Set it equal to 0 and factor out an x. Okay? Then what? Is that a difference of squares? Is that a difference of squares? No. So I can't do conjugate pairs unless I put something on it. You guys remember from yesterday? And I. So I can have x plus 2i and x minus 2i. Because with my conjugate pairs, that would be negative 4i squared. Correct? And the I squared would make it a positive 4. So my zeros, did you say 0 also? Okay. 0 and plus or minus 2i. Now, if you don't remember it factors that way, is that okay? Yeah. Yes. Can I set this equal to 0? So or solve just this. Could I do x squared equals negative 4? I do that, and then I take the square root of both sides, and I get what? Plus or minus 2i. But when you take the square root, don't forget your plus or minus.
I'm going to forget the I.
Well, with this negative, you're not going to forget the I, are you?
Oh, no?
No. So if that's what I'm saying. A lot of people, when they factor, when they do this, they forget that they have to have the I. So if you just set it equal to 0 and take the square root, you won't forget the I, but then people forget the what?
Plus or minus.
plus or minus. So you got to remember everything. Okay? So, x squared minus 6x plus 9. Factor it. Set it equals 0 first, right? And the reason I'm going to keep pushing that is because if it was equal to anything else, you'd have to move it over, correct? So factors of 9 that add to 6 are -3, -3, so it's x minus 3, but it's x minus 3 squared, yes? So it's x plus equals 3, but a multiplicity of what? 2. And so what does that mean? Do I go through the door or bounce off of it? Bounce, because it's an even. So if I were to graph that, actually that probably tells me that's the vertex of that, doesn't it? Because if you have one solution on a quadratic, then it has to be it's the vertex, right? Okay, what are you gonna do on the next one?
Move the 1 over.
Nope. Well, okay, what are you you want to move the one over? I shouldn't say nope. Then what are you gonna do?
Like fourth it.
The fourth root?
Yeah, that's what I meant.
Okay. Like what?
Quad,
So the fourth root. Okay, so what's the fourth root of 1?
1,
Nope.
1.
Nope.
Negative
4
1.
fourths.
Nope.
I.
Plus or minus 1. And, okay, let's factor it.
Plus or minus
Let's factor it.
X.
Okay, there's a reason why what you did isn't wrong. There's a reason why I don't want you to do it, Ainsley. Okay? So, x to the fourth minus 1, is that difference of squares? Yes? That would be x squared plus 1 and x squared minus 1. Yes?
Yeah, do it again.
Okay? And so then I have x minus 1 and x
Plus 1.
plus 1. What about this one? It's not difference of squares, it's sum of squares, so what has to be included?
I.
An I. So my answer is what?
I. And plus minus 1.
Plus or minus 1 and
I.
plus or minus I? Because how many solutions do I have to have? 4. Now, you guys would have told me x equals plus or minus 1, yes? If you would have got your act together and told me both at one time. How many are you missing? 2. So, I know that it's plus or minus 1 and plus or minus I because I've done this a million times. Are you going to know that?
No.
No. Well, you know it now, but are you going to remember it? No. So when we have the sum of squares, I'm going to see if I have it on the next slide. Is everyone good if I go?
Yeah.
Okay. If I don't, I'll write it. Okay, yep, I'm going to go back. Okay, when you have the sum of squares, and underline the sum. Bless you. So if I have a squared plus b squared, it equals, can you guys tell me?
I.
A
1.
squared.
A plus bi and a minus bi.
Okay, there is an I
Okay,
there.
they're conjugate pairs, but they're complex conjugate pairs, correct? Okay, so this might be something that you remember because could you use it from now on forever and ever?
Yes.
Yes. Now, are those going to be real solutions? No. And if you're looking for real solutions, well, then I don't even need to factor it, do I? But if I'm looking for all the solutions, do I need to do it?
Yep.
Yes. Okay, so rational zeros test. Okay? And it's the possible, I would just write this bottom one. Possible rational zeros. What word do I keep stressing?
Possible.
Possible. It doesn't tell you it doesn't tell you what they are. Again, just like the fundamental theorem of algebra, it tells you that the zeros exist. It doesn't tell you what they are. This tells you the possible rational zeros. What they could be. Now, this gets very long, but I'm going to tell you, we can have this or your possible solutions are infinity. Which one do you want? This. And you don't even know what it is, and you're still saying this. Okay, so the possible rational zeros are the factors of the constant term over the factors of the leading coefficient. There's no way to abbreviate that. I've tried over the years. I put FC over FLC and people go, huh? So, get all the words. You go to bed, you look tired.
I'm tired. I'm tired.
Okay, am I good? That's a first. It is, isn't it?
It really is.
Your table is noisy.
Huh?
You said your table is noisy.
One of the stools is really noisy too. Okay, Bladen, you good now?
Yes.
Okay, so find the rational zeros. Well, first of all, we need to do the PRZs. Ooh, what are the PRZs? I did abbreviate that. What are the PRZs? Look at what you...
Possible rational zeros.
Okay, possible rational zeros. It said the factors of the constant. What's the constant?
X.
No. What is the constant?
I don't know.
X. 6.
6. 6 is the constant, yes?
Yes.
What are the factors of 6?
3 and 2.
What about 1 and 6?
Sure.
Okay. But it would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And there's no commas in between there. Okay. Well, what is the factors of the leading coefficient? What is the leading coefficient? 1. Well, what's the factors of 1? 1. So plus or minus 1. Now, 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3, 6 over 1 is 6, right? Okay. If I had, let's say I had a plus or minus 2 down here. So there is possibly 2/3 as an answer. 3 halves. I'm like reciprocated brain today. Finding the zeros. We're going to use it to find the zeros. But are we going to... We got a lot of other choices. Are we going to start with 3 halves first? No. Okay, that would be like our ultimate last choice. Okay, so what we're doing is we need to find the zeros. So we normally would factor, yes? Do you know how to factor x to the 4th minus x cubed plus x squared minus 3x minus 6? No, you don't know how to factor that. If it was 4 terms, you could do factoring by grouping if it worked, right? But this is 5 terms. Do we have something that we could do to find factors? I think we did it Monday. I know we did it Monday. Well, quadratic formula, if we had a quadratic equation, we could do long division,
Or the other
but what was the other one?
synthetic.
Synthetic. If we synthetically divide by a number and the remainder is 0, does that tell me it is a 0 of the function?
Yes.
Yes. So we need to choose from plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6.
Let's do 3.
3? You guys want to do 3?
Yep.
Okay. So 3, do I have any gaps or holes? No. So 1, negative 1, 1, Negative 3, negative 6. And do your synthetic division, and I'll do it, and we better come out with the same thing, right?
Yes.
I want to stop. I want to stop right now. Why do I want to stop right now?
Because it's already not getting to work.
Because I need it to get to 0, yes? And if I do this one, I'm going to have 21, and then I'm going to have 18, and that is not going to get me to 0, is it? Nope. So if it's me personally on my paper, I go and erase this. And I change my negative 3 to, a positive 3 to a what? Negative 3. I already have it written. Might as well try it, right? Okay, so I have 1. Yeah, you do it, I'll do it.
You do it faster than me.
I don't think I want to keep going.
Yeah.
I think we should go with
Because we're going to go negative 39, and that's not getting us where we want, right? So I don't erase the 3. I don't erase that. I just try again. I just come over here. So 3 is gone, so I cross it off. You guys think 1? You guys think 1?
Yeah.
Okay, so 1. Now, you do get better at guessing. And when we're in class, I'll let you guess all day. Okay, so you do it, I do it. I'm stopping.
negative 1. You need to let me write it down before you stop. Well, negative 1 times 1 is 0. I mean, negative 1 plus 1 is 0, and everything times 0 equals 0.
Yeah, but I'd get 1, but I'm not going to get up to 6, am I? No.
2.
So, well, should we just try negative 1 since we have it here? Maybe. So, and you don't have to erase all of it, just part of it. Okay, so then that would be negative 1, so this would be negative 2. So this would be 2, 3, negative 3, negative 6, 6. Did it work?
Yeah.
Yeah. Okay. So we know that x equals negative 1 is one of them, right? Okay. Now, rational or real? Like rational or real numbers, guys. Okay. So are we going to get our imaginary numbers out of this? No. Okay. So, we went from 4th degree. What degree is this right here? 3rd. Remember, it goes down 1 degree. We still have factors of the constant over the factors of the leading coefficient. If the constant was 5, we could get rid of everything but 1. Okay? But the constant's still 6. Correct? Mm-hmm. If 3 didn't work on the original problem, is it going to work on this problem now? No. So, is negative 1 out? Could we use it again, maybe? Yeah, because we can have repeated zeros. We know that 1 doesn't work, correct? So 1 was out. So what do you want to try now?
2.
2? Okay. Now remember, don't start over. Just do your repeated from your answers. So 2. Oh, good guess. Good guess. Did 2 work?
You wouldn't know yet.
Yeah, you're going fast.
Guys, this is basic math.
Well, I can't get it
haven't
wrote
written it
down.
down yet.
Well, you're not rewriting it. You just went off what you had.
I know.
Okay. You're supposed to do it at the same time as me.
Not everyone's been doing math for years.
I was going to say, watch it. Watch it. Okay. So I know negative 1 and 2, yes? So I started off at 4th degree. I was at 3rd degree. And now I'm at what? 2nd. Do I have to keep going when I have a quadratic? No. I can factor or use the quadratic formula, yes?
Yes.
So I have x squared plus 3. Is that going to be a real solution?
No.
No. because that would be x squared equals negative 3. And then I'd take the square root. And so x would equal plus or minus the square root of 3 what? I. Are these real?
Nope.
No, not real. So the real or the rational are what? Okay, so these are rational. What if I wanted all? What would you write? I'd write negative 1 and 2. And what?
Plus or minus the square root of 3i.
Okay, so do you need to pay attention what I'm asking for?
Yes.
Real or rational gets you this, correct? All of them get you that. So our goal is to get it down to quadratic, because with quadratic we can set it equal to 0 and solve. We can set it equal to 0 and factor, or we can use the quadratic formula. We don't have to keep guessing on our possible rational zeros, do we? Nope. Okay. Oh, we had, this is the same thing. You had x equaled negative 1 and 2, yes? And then we had some non-real at plus or minus the square root of 3i. So if I told you to graph this, you'd put 1 to negative 1, right? And 2. It's a 4th degree positive, so what's it end? What's its end behavior? Up, up, right? But we have this going on there, right? I have a y-intercept at what? Negative 6. How do I know that's my y-intercept? Because all these would be what? Zeros, right? Okay, so negative 6. And something happens here, right? It like has a little wimpy, weird thing. So I'm going to go here, here. Actually, it's fine. Why did I not make it look like a normal parabola? It has something going on at plus or minus the square root of 3i. Now, theirs is the opposite way. That's what it would look like if you put it in your calculator. You can always sketch a graph and then put it in your calculator and see what it looks like, right? Okay. When I ask you to sketch a graph, though, I want you to sketch the graph. You. And then you can go check it. Because on a test, you're not going to have a calculator. And on a test, all I want to see is that you acknowledge the existence of this. You didn't just make it like this. Make sense? Oh.
I said fine.
Oh, I thought you said something else. Okay, so find all the rational zeros, and we're going ahead and graphing them because that's the whole point of this, right? Find zeros to graph. Okay, what are the PRZs? What does PRZ stand for?
Probable, rational.
Zeros. And it's possible, but probable, I'll go for it. Okay, what's on the numerator? Plus or minus 1 and plus or minus 3. It's the factors of the constant, right? What goes on the denominator? 1 and 2, factors of the leading coefficient. So I could have 1, 3, 1/2, or 3/2, couldn't I? See how I'm just making the fraction? If you look in the back of the book, you don't need to write this down. They're going to have plus or minus 1, plus or minus 3, plus or minus 1/2, plus or minus 3/2. If I asked you for them, what we write is absolutely fine. You do not need to list them all out because they could get really extensive, couldn't they? Okay, so holes or gaps in my equation? Nope. What do you want to try? 3? Everyone good with that? Okay. So you do it and I'll do it. And I'll wait. I'm stopping. Okay, I stopped after 9, guys. What's going to happen?
We're gonna go too high.
We're going to go too high. So we want to do -3 while we're here? Then I only have to erase 1. Did -3 work?
Yes.
Yes.
Mine did.
Mine did too.
Yours did too? Okay, now we started with the 3rd degree, so now we have a 2nd degree, yes? So now I can just factor or use the quadratic formula. So factors of 2 that add to 3, 2 and 1. So my zeros are what?
1/2 and 1.
What about -3?
Sure.
Okay, now this is a 4-term polynomial, yes? Could I have factored by grouping maybe?
Yes.
Let's see. Remember you can group in any 2 combination, right? We'll try the first 2. So that'd be 2x squared, yes? And then I would get not 2x squared, it'd just be x squared, wouldn't it? So x squared, and so I get 2x plus 3. And so I factor out a negative. That didn't work. Did it? Okay, so could I group the 2 and the 8 together? Okay, so if I group these 2 together, what do they have in common? 2x, -2, no, just 2x. And so I have,
X squared minus 4.
okay. And then,
3. X squared plus 1.
go away. Okay, I hit the little tab. So I get 3 and I get x squared plus 1. Okay, is this going to work for me to factor this by grouping? No. But is it sometimes, could it work for you? Yes. So just know that that is a possible thing to do. Okay, so we're going to graph it.
Okay.
Okay, so I need zeros at -3, 1/2, and 1. What's my end behavior on this?
One, wait, is it 1 down, 1 up?
One's down, one's up. Which one's what? It's positive, so it ends.
Down.
No, it ends up, so it starts
Yeah.
down. And we don't have any imaginary zeros, do we? No. We could do a y-intercept if we wanted. And a y-intercept on there? 3. So this graph has to go up here, down, and right back up, doesn't it? I wonder if we're close. You guys think we're close? Okay. Once I hit the next button, this is going to disappear. So you got to remember, or you have it on your paper. Oh, and it didn't even give it to me anyway. Yes, we are close. If we put that in the calculator, that's what it looked like. Sorry. Okay. Find all real solutions again and graph. I'm just saying the and graph because that's like the second part of this. Does that make sense? Okay. So is it in order? Probably should make sure that is, right? Okay, so PRZs.
12.
1, 2, 6.
6 and 2, 3 and 4.
I can't handle not having them in order. Sorry. Okay, so 1, 2, 3, 4, 6, and 12? Okay. What's in the denominator?
1 and 10, 2 and 5. That's it.
Okay. 1, 2, 5, 10?
Yep.
I think we do 4/5 first. What do you guys think?
Nope.
No.
This.
Yeah, there's a 4 in the numerator and a 5 in the denominator.
She was kidding.
I was kidding.
I was about to say.
Okay, we only have a third degree polynomial, so we only have to do this one time, right?
Yes.
Do you want to try to group it, see if that works?
Yeah, but there's no point in finding all those.
Well, yeah, it is, just to practice it. Do you want to try to group it?
Yes.
Okay. What do you want to try to group?
The first two, second two.
Okay, so then what? Negative 5x squared. And so you'd have 2x minus 3. And then you'd have 4. And you'd have 4x minus 3. So that didn't work. If you grouped these two, you would have negative 2x squared. So you have 5. Oh, that wouldn't be squared, would it?
You are dismissed. Please meet at the
And
bottom.
then minus
Landing
8.
upstairs at the front
I'm
door,
going to
please.
stop because that is not going to work, is it?
Students attending
Okay.
next capturing day,
So what do you want to try?
you are dismissed. Please meet at the front door.
What?
Backing up.
No.
4.
4?
Maybe not.
I think 4 is too big.
Yeah, that's what I'm by looking at it already.
I go.
Yeah.
Do negative 2.
What?
Do negative.
Negative 2? Oh, no.
That's already gonna be too big.
What about positive 2?
I don't know, man.
Try positive 2. Because that'd be negative 20, wouldn't it?
Then 5, 10.
It'd be negative 5.
Yes, it works.
Okay. So just because one of them is not going to work, like 2 was not going to work, or negative 2 was not going to work, was it?
Nope.
But 2 worked.
Yep.
So now we're down to negative 10x squared minus 5x plus 6. So 10x squared plus 5x minus 6. So the factors of 60 that have a difference of 5. What is that? 15 and 4. 12 goes in 5 times. Isn't 12 times 5 60? Okay, at this point my brain shut off. Could I just do the quadratic formula?
Yes.
Could I just do this again? Yeah, so I could do either one of those. So, real quick, I want to make sure. Okay, this right here are directions you get. Guys, do what we did. Did we find the possible rational zeros? Yes. Did we sketch a graph? Okay, they say sketch a graph before you find them. I don't care. Just graph it. Okay? Clear? Okay, if you have a ton of questions, work the best you can on everything. Try every problem tomorrow. We will go over every question on Tuesday. Okay?
Sounds good.
Turn in what you got, and we'll call it good.
Did you see my credit on it?
Yes. Oh, we got